Okay. Let's kind of start talking through this stuff. So it's gonna build off of yesterday and Friday or whatever's inverse stuff, where still same with inverses. Basically, your x and your y are flopping places with each other. Okay. So we're just gonna have some more theorems and stuff here that kind of build on that. So the first one there, inverse functions theorem. So it says two functions f and g are inverse functions if and only if, and then it gives you two different situations there. For all x in the domain of f, that g following function f of x is equal to x, and then they just switch it the other way. All that's saying is if you do the composite of the whatever the two things are, the original one and the inverse, if you do the composite of those, if you get x, they're inverses of each other. I'm going to give you a little example of that so you can kind of see. So an example of kind of that situation there, say we've got like g of x is like 1/2 x, and f of x is equal to 2x. Say they gave us those and they were like, hey, are these inverses of each other or not? What you can do is you can either do the fog or the Goff stuff that we worked the other day. So if I set this up as like the fog one, where I take whatever my function is here for g, put it into the function for f. You remember doing that with the fog and the Goff stuff? So if I take this stuff here and I put it in for that x, it would be like the 2 out front there for the f of x. We're plugging in that g of x into that spot. And then if I went to simplify that down, what's 2 times a half? What's half of 2? 1, right? So if it's 1 and it has an x, isn't that just x? Yeah, so if that kicks out an x, when I do that fog-Goff stuff, would those be inverses? They would be, right? Because that's what that's saying there. If you take those two values there, you do them as a composite, so either the fog or the Goff. If you solve them out and simplify and it comes all the way down to x, then they're inverses of each other. Okay, that's all that one's saying. The inverse function notation, that's just, and I think we wrote this the other day a little bit too, just we mentioned it in passing. So if you've got a function f, its inverse is written f to the power of that -1. That's just the symbol they use for inverse, just like when we did solving the matrices and we used that power of -1 button. It's the same thing, okay? So if you see something like that, it's just asking for the inverse. And then that power function inverse theorem, this is the one that gets a little bit confusing. So it says if f of x is equal to x to the power of n and g of x is equal to x to the power of 1 over n, and the domains of f and g are the set of non-negative real integers, then f and g are inverse functions. So let's talk through what they mean with like the non-negative real numbers. So I got two graphs here I'm going to set up. One, they want us to set our domain as non-negative real, so like just, +1, +2, that kind of thing. And then the other one, we're going to go all real, so we can include 0, we can include the negatives, okay? So if I'm just going to do a basic graph here of, say my original graph was like y is equal to x squared for both of these. If I came up with just some ordered pairs here for my x and y, we could just take that into our calculator. Go to our y equals x to the power of 2. Grapher, we get that parabola. Go to our table there, and then you're scrolling to where you find like the middle. Well, our middle there is at 0, 0. Oops, let's see what that reflection there. Our middle there is at 0, 0, so we'd use that as the middle point, and then do a couple, above it and a couple below it. So I would just write down a handful of those. So like I said, the middle there, 0, 0, and then I just do a couple above. So like -1 and -2, -2's at 4, -1's at 1, and then I'd just do the same thing the other way, do a +1 and a +2, and that would also be at 1 and 4 because, we picked that because it's the middle of the pattern. So if I'm doing that out there, and now I want the inverse of that, what did we do yesterday to get the inverse of that? Remember? Yep, flip the x's and the y's, right? So if we switch that equation, it would switch to, I'm going to do this in a different color, it would switch to x is equal to y squared. So just switching your x and y, and then you can do the same thing with your ordered pairs. You just take all your x's and y's and flip them around. So like my 4, 1, 0, 1, 4 is now in my x spot. My -2, -1, 0, 1, and 2 is now in my y spot. Now here what they want us to do is they want us to just focus on the non-negative real numbers for our domain. So if we're just focusing on the non-negative real numbers, that would include 0 and everything that's positive, okay? So like here, if we're just focusing on that, that would just be those ones that we would be graphing. Same here, if our domain were just focusing on the non-negative ones, that would be that stuff there. And again, that's because we're going non-negative real numbers on that, okay? I know it's kind of hard to read there, okay? But we're just focusing on those. So if we just graph those ones out, so if I graph like this one here, the ones that I just boxed in there, so 0, 0, 1, 1, 2, 4, next one would be 3, 9 if you wanted another one on there. If I graph that out, got something that looks like that. And then if I graph my other one out, I got 0, 0 again, 1, 1 again, and then I got 4, 2. And then the next one would be 9, 3 again if you wanted another one on there. So if I graph just that part of it out, what do we think about both of those graphs? Would they be functions or not functions? And to be a function, originally to be a function, it would pass the vertical line test. So would both of those pass a vertical line test? Yes, they would both pass a vertical line test individually, like the green one and the blue one separate, would pass a vertical line test. So that's going to make that a function, okay? Now what happens, and we talked a little bit about this yesterday, when we do all real numbers versus the non-negatives, so now I'm just going to do the same thing. I'm going to do my graphs here, but instead of just boxing off certain ones, I'm just going to list them all out. So like my table for my original one, I'm just going to copy the same table I had over here, so it'll be like -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. And then graph that out, and again, it'll look kind of similar, because we had the one half of it already. But then you're also going to have the other half of it, because now we're all reals. So then obviously you can see there that we just get the other half of that, because now we're all real numbers. So looking at our original there, what do we think? Function or not function? If I go vertical line test, that one's good to go, function, right? Now when I switch to the other one, again, I'm just going to take this same one I did here, but just graph all the stuff out instead. So that one was x is equal to y squared that time. Just switching the x and y. And again, I'm just taking those same order pairs and switching them. So 4, 1, 0, 1, 4. And then -2, -1, 0, 1, 2. So then if we get that guy graphed, so if I do that guy out then for my inverse, what do we think about that one that I just drew down here? What do you think, function or not a function? If I do vertical line test on that guy, what do you think? Not a function, right? Because it'd be crossing on like top and bottom there. So that one says underneath there's not a function on that, okay? So sometimes they might have situations like that where they say, hey, just focus on like the non-negative reals or whatever. It's for reasons like this, so you can possibly turn it into a function, because otherwise if you graph the full thing out with all real numbers, then the one's not going to be a function of it, okay? And I know that gets a little bit confusing, but that's kind of the gist of that. Okay, and then we'll just go to our example sheet for the last thing here. And there's just one example today. There are a couple ways to go about this. One way to do so, basically we got a function or whatever here. We got h of x is equal to 4 parentheses x plus 7 minus 3 over 2. And then they want us to find the rule for h to the power of -1. Remember that we wrote in our notes that just means we're finding the inverse of that h of x. Okay, so that power of -1 just means inverse. So there's a couple ways we can go about this. We can either start by switching our x and our y around, or we could do a little bit of simplifying here and then switch our x and our y around. What do you think? Do you care? Okay. Let's simplify first. I got a little note to myself that one's easier. So let's simplify this down a little bit first, maybe, to get it a little bit more concise, and then maybe we'll do our stuff here. So if we're starting off here, h of x is 4 parentheses x plus 7 minus 3 over 2. We know h of x, when we're talking about like switching our x and y, we know that's kind of similar to the y, right? You know, it doesn't say y, but you know, in our concepts, it's the same thing if we're switching stuff. So here, like I said, I got a note to myself that it's easier to simplify this stuff a little bit first. So like here, we know we could take that 4 and kind of distribute through there, right, to make it a little bit more simplified. So like if I took the 4 times the x, it'd be like 4x. 4 times the 7 would be 28, minus the 3 over 2. And then from there, we could probably also combine the 28 and the 3 together, right, because they're both on the top. So I could go 28 minus 3, which would be 25. So then I'd have like 4x plus 25 over 2. And like I said, the only reason we were doing that there is just because it's just a little bit more simplified version down of that. So now that was just us simplifying a little bit. Now if we're trying to find the inverse, like I said, we're just taking our x and our y and we're switching those around, right? So if I think of this as my y, that is my x. If I switch those, it'd be like x is equal to, and then 4y plus 25 over 2, and this is when we're doing the actual inverse out. So now if I'm going to try to get that y by itself, probably thinking I want to get rid of this big division first here, and we know the opposite of divide is multiply. So I'm probably thinking multiply everything by 2 first. So gone, gone. 2 times x would be 2x. It's equal to, those 2's are gone, so just 4y plus 25. Then from there, we know we got to get rid of add 25 by subtracting 25. So 2x minus 25 is equal to, that's gone, so 4y. And then our last step there, divide by 4. So the 4's are gone, so we'd have y is equal to that 2x minus 25 over 4. And then just because it says find the rule for like h of, you know, -1 or whatever for the inverse, you could just switch this to h to the -1 is equal to 2x minus 25 over 4. They mean the same thing, but just to follow their little notation there, if you want to do that. You could also split that into 2 parts and have one as like 2 over 4 x, and then minus 25 over 4x. I don't care. This is fine with me. Okay? All right, so it should be similar to yesterday's stuff. I know we got some extra stuff kind of mixed in here, but it should be kind of building off of yesterday. So you got that book page for tomorrow, 1 to 21, skip 5, and then skip 11, 12, and 13.